This is Twit.
Bandwidth for Know-How is brought to you by CashFly.
This episode of Know How is brought to you by iFixit. Introducing the all-new ProTech Toolkit to give you the compact and complete toolkit for all things DIY. For $5 off your purchase of $10 or more, go to iFixit.com/twit and enter the code KNOWHOW at checkout. And by DigitalOcean. Simple and fast cloud hosting built for developers. Deploy an SSD cloud server in 55 seconds. Try it today for free. Visit DigitalOcean.com, and once you sign up, be sure to enter the promo code KNOWHOW in the billing section to get your $10 credit. On today's show,
you'll know how to control your stepper motor with an Arduino.
Welcome to Know How. It's the Twitch show where we build, bend, break, and upgrade. I'm Father Robert Ballecer.
I'm Bryan Burnett.
And for the next 30 to 45 minutes, we're going to be showing you some of the projects that we've been geeking out to, so you can take them home and geek out on your own.
That's right. That's right. And so it seems like we've already got a few little gadgets on the table here, Padre.
We do.
We got an Arduino here.
Well, Arduino, we love the Arduino. It's an all-purpose gadget. It allows us to do a lot of different types of projects. One of the projects that was most requested of us over the last couple of months has been using an Arduino with a stepper motor. Now, we've used Arduinos to control servos,
right,
but stepper motors can do much of the same job as a servo, but better.
But better. Okay, I remember one of the questions someone asked was how could they control their chicken coop door opening using a Arduino and a motor?
Right.
So.
And some people in that posting suggested just getting one of those big torque servo motors. And you could do that. You could totally do that. Yeah. The thing is, getting a servo that is that size is kind of expensive. And
you can't just like pull it out of a car or something like that.
No. I mean, you'd like use a hydraulic or a linear actuator, but a stepper motor actually could do that quite well, quite cheaply, and with not too much gear that you don't already have.
Sweet.
Yeah. So first thing I think what we need to do is we need to clear up the difference between a servo and a stepper motor, because there's going to be a lot of people who are going to say, wait a minute, I can do that with X, I could do that with Y. And the truth is, yes, there's a lot of different ways that you can accomplish the project that we're going to show you today, but we want to show you how to do it with a stepper motor. Now this right here, this is a servo. Now, we've seen this on the show before. We use these in RC models. We use this in Project Lunchbox. You'll see these anytime you see, like this one's actually for a model aircraft. It's a 35-gram micro servo. Now, quite simply, all this is a motor with a gearbox connected to the shaft and some sort of potentiometer. Now, we know from our Project Arduino that a potentiometer can just vary the amount of resistance that it's giving to any given line. In this particular case, we use it to vary the amount of voltage that goes back into the Arduino so that we can set a certain value to it, right?
Right.
That's what we've done in the past. What this will do is this will allow us to do the same thing. I'm actually going to demonstrate it. I've got the servo, I've got a servo tester, and I've got a power supply. This is the standard universal battery eliminator circuit that we've been playing with for a while. So let me go ahead and hook this up. Positive, negative, give it some power. Okay, now as I turn this, you can hear the sound.
So if we had like a little propeller or something on there, you'd see it turn.
Yeah, actually, I think I have something. I'm pretty sure. Yes, there. This will make it visible, so you can actually see it on camera. I have the ability to change the value of this potentiometer, which is then encoded onto that servo.
Right.
Oh, wow, our focus has gone all the way down there. Okay, so and this is why we use this kind of technology. This is PWM. We use this for positioning things on, say, our quadcopter when we want to control the throttles.
Right.
And it is pretty exact. But once I start getting up from this base model, I do get kind of expensive, I do get kind of heavy, and I do get kind of complicated, because this is a complicated servo mechanism. You do have that motor, you do have all those gears, and then you also have that potentiometer that gives me a little bit of feedback control.
Okay. So now, what's a stepper motor?
Let's look at a stepper motor. A stepper motor looks like this. This is actually one of the most basic stepper motors that you can get. We're going to talk about the model in just a bit. This, along with its driver, and we're going to explain why we need a driver in just a bit, costs less than $2 on eBay. I bought like a box of 10 of these for like $17. It was ridiculous. It was fantastic. Now, they are far, far less complicated than a servo. So a servo is a motor that uses a few poles, say 4 to 12, whereas a stepper motor can use 50 to 100 plus poles. And the reason why that's going to be important is because it allows me to have fine control over where the motor stops inside its rotational range.
Okay, so when you say pole, that's the amount that it moves?
The number of windings, the number of magnets that it has. So imagine this, on a servo motor, the motor rotates a potentiometer, and then that value will let the servo know when it's supposed to stop.
Okay, right.
On a stepper motor, because there are so many poles, the motor naturally wants to stop along certain spots in its rotation, right? If you've ever played with a motor, you notice that sometimes it's easier to turn, sometimes it's harder to turn.
Right.
It's flipping between poles.
Okay.
Well, if you have more poles, you have more places where the motor wants to stop.
That makes sense. Okay.
So what I can do with the stepper motor is I can have much of the same fine positional control, but I get it in a much less expensive package, in one that can provide way, way more torque, and one that is, well, it's a lot less expensive to drive.
Is it more reliable? Like, is there a chance that it would last longer than if you're going to use a servo for certain projects?
Yes, and primarily because the servo motor will use a complicated gearbox with that potentiometer. Anything in there can jam. If the potentiometer breaks, it doesn't work.
Right.
One of the gears break, it doesn't work. If the motor starts to go out, it doesn't work. Stepper motors are they're big, dumb devices.
Okay.
And as long as you pulse power to them the right way, they'll go ahead and rotate.
Cool.
Okay. Now let's go ahead and go down a few of the things that you'll want to know if you are considering either a stepper motor or a servo motor for your project. A stepper motor, you're going to want to use it when you have a lot of torque necessary. So if you have something that it's heavy and it needs to be rotated,
Like a door hinge
a
or
door, a
something?
hinge, right. Stepper motors are much better because they have way more low-end torque.
Okay.
Versus servo motors actually have more torque once they hit the top of their speed range. So, I mean, consider that. It's sort of like comparing a gas engine and an electric engine. You need to choose the right one for the application that you're doing.
Okay.
The other thing to remember is, of course, a stepper motor is less complicated. It doesn't have a potentiometer or normally it doesn't have a potentiometer like a servo.
Right.
But it does require a driver board. Whereas the servo, I'm running it off of 5 volts and a digital signal.
Yeah.
You're going to see in a bit, it takes a bit more to run a stepper.
Okay, yeah, because we've got this is the driver board you're talking about?
Right, that's a driver board. So we can't just plug this straight into our Arduino. First of all, there's not enough power. Secondly, we need this. This is the logic that will help me translate pulses from the Arduino into something the stepper motor should actually do.
Ah, okay.
Yeah. Now this is important. When we've been dealing with two-phase motors, like the DC motor we had in our project lunchbox. Very simple. You provide power in one direction, it rotates one direction. You switch that power, it rotates the other direction.
Yeah.
The three-phase engines that we've been using on our quadcopters, it's a little bit more complicated because now you have 3 phases, you have 3 poles that you're playing with, but the the electronic speed controller automatically does all the switching for you.
Okay.
With the stepper motor, you'll notice, Alex, if you go to the overhead here, there's actually 5 wires coming out of this, and one of them is ground, but the other 4 are the 4 phases of this motor. And the way that I rotate this is that I don't just apply power to it. I have to pulse signal. I have to pulse the power in a certain pattern in order to make this rotate from step to step to step to step.
Okay, because each step, is it just little magnets that it's?
Yeah. Well, and we'll see that in just a bit. Okay. So now this is a 28BYJ-48 motor, and this is a ULN 2003 driver board. Alex, I have a link here. You can get these on eBay. In fact, this is not even the cheapest. I found them on eBay. Go ahead and buy yourself a bunch of these because they're great to test with. They're very easy to set up, and they're cheap. I like cheap.
Yeah, $2 for one.
Cheap is muy, muy good. Now go ahead and show that the image that I put in there, Alex, because that's going to show them how one of these works. There's some important specs. Leave this up. First of all, they'll leave it up. There. Go back to the picture. that we had. There we go. So we've got a couple of pieces of information that we can take from this. First of all, it is a 5-volt motor, which is good because that means that I'm going to be able to power it using the same 5-volt power source I'm using for my Arduino. I know that it's 4-phase. I know, and now this is important, the stride angle is 5.625 and the speed variation ratio is 1:64. What that tells me is that every time this motor steps, it's rotating 5.625 degrees of the 360 degrees around the shaft.
Okay.
So every pulse moves the motor that much. However, the modifier of this is the speed variation ratio. It's going through a small gearbox. That means that the motor needs to turn 64 times
To do a full 360?
to do a full 360 of the shaft on the outside of the casing.
Ah, okay.
Okay. Now, there's a little bit of math here, but that stride angle of 5.625 gives us 64 steps. It's 360 divided by 5.625, 64 steps for the motor to rotate fully. But because it's geared down 64 times, we have to multiply that by 64, which is going to give us 4,096. So in order for this motor to turn the shaft on the outside of the casing 360 degrees, it needs to step 4,096 times.
Okay. Now that adds up. That makes sense. And that's what you're going to be that's what the driver board's programmed to do?
Well, that's what we're going to program the Arduino to do.
Okay.
But just remember, in order for this motor to make it remember, there's the motor and then there's the shaft.
There's the shaft, right.
So in order for that shaft on the outside to make it all the way around 360 degrees, that motor has to be pulsed 4,096 times.
Got it. And if you wanted to do if you wanted to do a 180, you would do half that
2048,
number.
right?
Yeah.
Exactly. You want to go, and then actually it's kind of binary down from the 1056 or 1028 and so on and so forth.
Cool.
So
Okay.
what does this mean? This means that we can build an application using an Arduino where the Arduino can automatically go one full rotation this way by going 4,096 pulses, and then we're going to reverse rotation and make it go one full revolution the other way. And this will allow us to demonstrate the basic principle of using a stepper motor with an Arduino.
No, that's really cool. And like, if you're going to be doing that for the chicken coop idea, where you open and close the door, you could set that on a timer to do, this much of a rotation at this time, and then at the end of the day, when the sun's setting, close the door.
Precisely. All right. So let's do it. Let's go ahead and do some building. A few of the things that we're going to need. If you go to the overhead, Alex, we are going to need this. So we've got our stepper motor and our driver. Again, this is the 8B motor, and this is a 2003 driver board. This will give me a place to put power, a place to plug in my motor, and then pins to connect to my Arduino. I'm also going to need my Arduino of choice. Again, I'm using the Uno just because this is sort of our demonstration model. It has a breadboard that we're not really going to need, along with some potentiometers. I can run this on any Uno. This is actually very simple code. So if you have a Uno Nano, if you have a Micro, if a Pro,
doesn't matter.
Just know where your pins are. I'm also going to need a 5-volt power supply. I got this here. This is the UBEC that we've been using for so many different projects.
Right. So you can draw power from
pretty much anything.
Yeah.
Yeah. This will take it all the way from, I think, 7.4 volts up to 30 volts. So any of that will give me nice, clean 5-volt power out of here.
Cool.
Okay. I'm also going to need some jumpers because I need to be able to connect this to this. All right. So this is the first project where I'm going to ask everyone to separate power supplies. In the past, we've been running like our LED lights off of the internal power source of the Arduino, and we can kind of get away with that. Stepper motors, you really don't want to do that, because what will happen is if it gets bogged down, like if there's too much force being exerted against the rotation of the shaft, it will jump its power consumption, and it could jump it past the point that the Arduino could supply, and then you end up
blowing a little fuse on the Arduino?
Well, blue smoke in the Arduino. So we're going to have a separate power supply for the motor and the driver board than we do from the Arduino. The Arduino's being powered off my computer right now, but this the stepper motor is going to be
on the battery
off of this, right?
Cool.
So if you go to the side view, I think the side view has a tighter shot. There we go. So the first thing we want to do is we want to locate this little row of pins right here. That's the switch. So this little, if you could digital zoom on that, Alex, if right here, this is a jumper that tells the board whether or not it's going to be on. So right now it's set to on, but I also could connect this to an external power switch if I wanted the ability to turn this on and off, right?
Okay.
Okay. This is where I put power, and I don't know if you could see, but I've got positive on the inside and I've got ground on the outside. So I'm going to go ahead and hook that up now. Positive on the inside, ground on the outside.
It says 5 to 12 volts on there.
Right. There we go. So I'm going to give it 5 volts. I also need to hook my motor up. Now this one's easy. There's only one plug where the motor plug will connect to.
It has little guides, yeah.
Yeah. Now, what I need to do is I need to connect this to my Arduino. There are 4 pins here, and I actually need all 4. I'm going to show you why I need all 4 in a bit. I'm going to take this length of lead. I'm just going to make sure I'm going black, white, gray, and then purple. So that one will be my 1, 2, 3, 4. These are labeled IN1, IN2, IN3, and IN4.
Okay.
Let's see if I can get that into the camera. There we go.
There you are.
Okay. So I'm just going to do this. Like.
Easy does it. Easy.
Stay on target.
There are 4 wires.
There are 4. Now what I need to do is I need to connect it to my Arduino. I'm going to go ahead and disconnect this power for a second. Now, you have a bunch of pins depending on which Arduino you're using. Go to the side view again, Alex. Here, if you do the digital zoom, Alex, please, you'll see you've got all the way from 1 up to 13. So on this Uno, I've got 13 digital pins that I can play with.
Right.
What I'm going to do is I'm going to go ahead and put it here. I'm going to put it in the upper range of the register. Upper range of the register. So I'm going to put it 8, 9, 10, and 11.
Okay.
All right. So I'm going to do this.
8, 9,
So
10.
pin 1, which was the black one, is going to be 8, and pin 4, which was the purple one, is going to be 11.
And all 4 of these pins, are they just to send the signal to tell the stepper motor which direction to move?
Right. So each of these has the ability to pulse to the driver board, which will then tell the stepper motor which way it's supposed to be turning.
So then it's deciphered by the controller on here?
Kind of. The controller is really just passing it on.
Okay.
Because the driver board is designed so that you can power it from an external logic. But this is doing all the logic, and we're actually going to show you the programming. You'll see the logic that's necessary to make this thing turn.
Okay.
So I'm going to go ahead and power up, and hopefully I don't get blue smoke.
You shouldn't, right?
Okay, which is good. So this is what I want. The driver board is powered up, because I know that because I see it's supplying power through the UBAC.
Right.
But I'm getting no lights. And the reason why I'm getting no lights is because I'm not yet receiving any signal from this Arduino.
Okay.
Now I have pre-programmed this Arduino, but I pre-programmed it incorrectly. I'm going to show you in just a bit.
For demonstration purposes?
For demonstration purposes.
Okay.
There we go. And if you go ahead and go over to my 11 really quickly, we're going to show them some quick programming. You'll notice that I have here IN1, 2, 3, and 4. So I've created these variables to take in or to push out bits to those 4 pins I connected between the driver board and the Arduino, right?
Right.
And those numbers correspond
To the pins?
to the pin on the Arduino, but I did not connect it to 4, 5, 6, 7. What did I connect it to?
You did 8, 9, 10, and 11.
So that's what I have to change it to. So let's go ahead and change this. IN1 is connected to 8. IN2 is connected to 9, IN3 is connected to 10, and IN4 is connected to 11. All right, so now if I upload this,
should the lights come on the driver board then?
You'll see it in just a bit. It's gonna see. Now, if you move your hand so that you can see, there you go. So you'll see that these lights are pulsing, and that's because the Arduino is sending pulse signals to this. And this motor is actually turning. You can't see it because it doesn't have anything on it, but let me do this. Where are you? There. So you can see this is slowly turning this stepper motor.
Yeah. And it looks like it's getting to a certain point and then bouncing back.
Right. So I have this code set to do about 360 degrees and then bounce back. Now, we're going to show them all that programming and how it works in just a bit, because what we want to do is we want to take you through the steps of actually programming something like this. This is not going to be a black box. The hardware is actually really simple. I didn't even have to use my breadboard. It was basically provide power to the Arduino, connect 4 pins to the driver board, supply power to the driver board, and I'm good to go.
Nice.
But the software gets a little tricky. We're going to explain that when we come back. But first, you know what I want to do, Brian?
Thank a sponsor?
I want to thank a sponsor, and not just any sponsor. I want to thank the sponsor who has been with Know-How from just about the beginning, at least the beginning of my time here on the show. And they provided us with everything we need to be the best DIY makers possible. Of course, I'm speaking of iFixit. Now, iFixit gets makers. They understand that we don't just need the parts and the tools. We also need expertly put together manuals. Do you want to know how to disassemble your Xbox? They've got that. Do you want to know how you do eyeglass or household upholstery repair? They've got that. Do you want to know how to disassemble your iPhone or your iPad or your Android device to replace a broken screen? You can do that because iFixit has all the repair guides and the tools that you'll ever need. Now, here on Know How, we are celebrating the fact that iFixit has a brand new kit. It's the all-new ProTech Toolkit. Now, not only are they your complete DIY electronics repair solution, Spot, but their 19,000 free step-by-step guides combined with this makes it the unstoppable force in DIY making. Now, this new kit is gorgeous. It's completely reimagined. It's just as rugged and portable as before, but now it's easier to use because of this. They've added a magnetic tray. It allows you to keep your bits in easily accessible positions, and yet they'll stick back in, so you'll never lose a bit again. They also include things like a precision ESD safe tweezers, more bits, 64 this time instead of 54, and a wider variety of plastic opening tools and picks to safely work on tablets and smartphones. iFixit also gives you suction cups for display assembly removal, metal spudgers, and iFixit's own rubber-handed Jimmy pry tool. Now, their ESD safety strap makes it so that you don't destroy the work that you're trying to put together. And the best part is that everything is backed by iFixit's lifetime warranty. Buy it because it's awesome, or don't. And you'll still get free access to all the free repair resources on iFixit.com. But once you get a taste of iFixit's goodness, as Cranky Hippo and myself have, I know that you're going to fall in love. Go ahead and do yourself a favor. Grab an all-new ProTech Toolkit and get going on your next fix, hack, or build. Just head over to iFixit.com/twit. That's iFixit.com/twit. Use the code KNOWHOW at checkout to get $5 off your purchase of $10 or more. Once again, we thank iFixit for their support of Know How. Hey, Brian, I want to get programming, but first what I want to do is I want to address a little something. A few weeks back on new screensavers, I was with Leo Laporte and we had a call for help. The caller was looking for an inexpensive way to do pan, tilt, and zoom on his camera because he wanted to be able to control one remotely. He didn't want to spend a lot of money. A lot of the solutions that are out there, you've seen them.
They're pretty expensive.
They're pretty expensive.
Just get a Panasonic PTZ, like we used at NAV.
10 grand?
I don't know, were they 10 grand?
Yeah, I don't know. Well, I told him that I would start working on a solution, a project that maybe could fix his PTZ lust. And believe it or not, it's going to start with stepper motors. But before we take a look at the programming that's going to make this be his ultimate PTZ device, let's take a look at some PTZ done right. Conventional wisdom tells us that rail shots are expensive, complicated, and not for, well, the amateur. Well, here at Syrup, they're here to prove that conventional wisdom is wrong. I'm speaking with Ben, who's going to show us why the Genie and the Genie Mini is your next gear of lust. Ben, what is the Genie?
So yeah, the Genie's a really portable solution for motion control, time-lapse, or video. So it's basically this one simple box, and it basically clicks out and clicks into different film equipment. So I can put this onto a slider or a tripod. So if I click it into a slider here, I can now control everything to move along a track for motion control, time-lapse, or video. And then I can just unclick the same unit and put it onto a tripod. And now I'm setting everything up on a tripod to shoot time-lapse or video motion in a panning direction. So it's either for panning motion or linear motion in its sort of simplest form.
What I really like about this is we can see here, this track, this camera is just going back and forth, and it will pan the camera according to an app. So you've got an easy-to-use app that will allow you to set speed. It will allow you to set how many degrees it's going to be spinning. It will even let you determine distance, how far down the track you want it to go. And then I can pop the entire unit off and use it as a time-lapse PTZ. Yep. What gave you the idea to make this modular design? Because I've seen products like this, but they always lock you in. It's their rail, it's their tripod, it's their camera. You've given us a system that will work with all the gear that I currently own.
Yeah, exactly. So when we built this thing, we really wanted to focus on, what people need to add to their kit. So lots of people already have sliders. Everyone's got a slider. So rather than, you can buy our slider. I mean, we do sliders as well, but you can just buy the Genie and click it into your own slider and then add motion that way. So that's the single axis way that we can add motion. And then we can also put the Genie Mini on top, and then it becomes app controlled. So then everything's wirelessly controlled. We can even link 2 Genie Minis together to do 3 axis, like this one's doing here. And then everything's controlled on the app for pan, tilt, and track motion.
And I really like that part, where I can start with the basic module. I can add a mini if I want to give myself movement in this axis, add another mini if I want to give myself some X action here. Now, tell me, where else are you going to go with this? Because the modular system, the beauty of that kind of a design is you can add on accessories as you go. What's the next big accessory?
Well, the next big accessory is a slingshot, which is our cable cam product. So, yeah, this is a new product for us. I guess when we built the Genie, we had a lot of users building their own systems. Because you can use a Genie on anything, we had users building big, long cable cams, using them on skateboards, using the Genie on literally anything they can build, so a big DIY community. And one of the biggest demands that we had was for a professional cable cam. So we've built our own now. So you can sling this up like up to 100 meters or 300 feet. You could, between buildings, across a lake, like wherever, and go really, really, really long for those super long motion shots. So this is a very unique type of shot that you can get. I'm not aware of really any other company that can do a time lapse that long. So yeah, it's like a really, really cool shot.
You were telling me earlier that the battery life can be anywhere from 24 to 48 hours, depending on which unit you're using. Now, let's ask the difficult question here. We've got audience members who are going to be wondering where they get one of these and how much they cost. We were just in a booth on the other side of the hall that had a similar rail system that cost about $4,500. If I wanted to get a Genie from Syrup, how much would it set me back?
So the Genie is $789 US. So that includes everything, the panning accessory, the linear accessory, and a cable. So you can literally attach that to any slider or whatever you want for $789. So yeah, pretty cheap. And then you can go, the Mini is $249, and the bracket is $89. So for a full 3-axis motion kit, you're looking at about $1,200 to $1,500.
That's unbelievable. So one of the best features I've seen, and also the lowest price in the hall. Ben, if they wanted to find out more about Syrup, if they wanted to find out more about the Genie Mini, about all of the accessories that you offer, where can they go?
Yeah, so our website's syrup.co.nz. So www.syrp.co.nz.
Thank you again for speaking with us. Thank you for sharing your tech. And folks, the future of pan, tilt, and zoom needs a Genie.
I liked that solution because of the modularity. I like the ability to sort of like start with one module and then add a stepper on top of that, and then maybe add the little attachment so it can ride across wires.
Right. Yeah, I like the little attachment. At first I was like, well, why wouldn't you just have a drone? And then he's like, oh, you can't get a time lapse for that long. And I was like, okay, that makes sense. But yeah, those are some cool little products they had.
Cool products, but here's the thing. Those are just stepper motors. That's what they're using inside of that.
Okay, so you're saying we can build one?
We could build one. Now, they're not using the cheap sub $2 stepper motor that we bought.
They seemed a little
project.
bit more refined.
They're more refined, they're more robust, they have higher torque, because one of the issues that you're going to run into with stepper motors is, since they don't have a feedback mechanism like servos. So servos, that the position of that internal potentiometer, that tells them where it is in its rotational cycle. A stepper motor, you're just pulsing. You pulse the position to it. So if I say, well, to go from this position to this position, I have to move 2,048 times.
Right.
I'm pulsing it 2,048 times, and I'm assuming that the stepper motor has moved 2,048 times.
Right, there's no verification.
There's no verification unless I add some sort of rotary encoder, which we can do. Like, for example, the gimbal on an active gimbal on a quadcopter, those are just 2 stepper motors. But it has that little IMU, the balance board. So it knows if it's this degrees off, it pushes the motor the other way until it's back down to 0.
Ah, okay, right? Cool.
But for us, because we're not really using any feedback mechanism right now, we just have to know that if you pulse too quickly, the stepper motor can actually miss a step or miss a couple of steps. Or if you apply enough force so that it stops the motor from actually moving, it will actually just it will vibrate but not move, and then it thinks it's moved its 2,048 steps, but it hasn't moved anywhere.
Okay.
Just know that. Just know that. Yeah. Now, we're going to go ahead and get into the programming to make that all happen. But before we do that, let's go ahead and thank the second sponsor of Know How. Hey, Bryan, you know what I like?
What's that?
I like being on the internet.
Yeah, that's one of my favorite things.
It's kind of what we do, right?
Yeah, every day.
Yeah. Now, the old way of getting on the internet normally involved you talking to some sort of ISP, maybe a colo, maybe getting your own dedicated hardware. If you're going to do financial transactions, of course, you have to, make a nice arrangement with someone who's going to take care of that part for you. And then there's always the maintenance. You could still do that if you really wanted to build up your own industry from the ground up, if you wanted to build up your own business and have everything on your own. But that would just be silly. That's expensive. That's time consuming, especially when we've got DigitalOcean. Now, DigitalOcean is the way to develop in the new era. You see, whether you're developing an app, a website, or working on a server-based project, DigitalOcean will give you a flexible, reliable, and affordable way to host. They give you droplets. These are virtual private servers that are contained within themselves. So it allows you to wrap up your server, wrap up your app, wrap up your next great website, and then run it anywhere on DigitalOcean's infrastructure. It's used by over 600,000 developers, including Twit's Randall Schwartz, by Aaron Newcomb, and myself. It lets you deploy and configure your droplets via a streamlined control panel or a simple API. It also lets you choose your OS. This is a service that a lot of others don't let you do. You want Ubuntu? How about CentOS, Debian, Fedora, Core OS, and FreeBSD? You can select from one of the many pre-configured one-clicks like Drupal, Docker, or Node.js if you want to get up and running quickly, or you could use their root access to servers running 100% SSDs to build your own infrastructure exactly the way that you want. It's highly scalable to meet your demands, which means you can start with a single instance, a single droplet running on just a few CPUs just to test, and then open it up to worldwide distribution with the click of a slider. Now, they've got an extremely active community, and this is one of the things that I look for when I'm looking for a new service. If the users come back, if they try to encourage new users, if they try to pass on their knowledge, it tells me that they've got an active community, and they've got a community who loves the product. That's exactly what DigitalOcean does for its users. And it's so easy to get started, you can deploy an SSD cloud server in as little as 55 seconds. Are you out of excuses yet? Because you should be. I mean, if you've got one, maybe it's price, but let me get rid of that. Because DigitalOcean has incredibly affordable and straightforward pricing, with servers starting at just $5 per month. There's also hourly pricing available, starting at less than a penny per hour. But we're going to make it so that you can get started today and deploy an SSD cloud server for free. Just visit DigitalOcean.com and create an account. Once you confirm your email and account information, go to the billing section and enter the promo code KNOWHOW for a free $10 credit. That's plenty to get started and explore what DigitalOcean can do for you. Again, that's DigitalOcean.com, DigitalOcean.com. And once you sign up, enter the code KNOWHOW in the billing section to get your $10 credit for free. And we thank DigitalOcean for the support of KnowHow. Hey, Brian, you ready to get programming?
Yes, let's dig into some code.
Now, first of all, I do want to say that all the code that we're about to see is fully commented, and it's already up on our public server. So
you should just make people figure it out.
So as soon as the show goes live, it will be in the show notes, along with the 3D parts for the devices that I've been creating. Like, for example, this is what we're actually making. If you go to the side shot there, Alex. There we go. So this is just a stepper motor connected to an Arduino and a little 3D printed frame that I created.
Just a little guy.
It's just a little guy, but it's moving a GoPro. And so what I had this doing the other day is I was moving it much more slowly than this.
Yeah.
But it was doing that cool kind of pan across.
While doing like a time lapse or sort of thing? Yeah, nice.
It was very cool. And the nice thing is it takes up so little power, and because it's just rotational energy, I can do so many different things with this. In fact, I'm going to show you a little something afterwards that's going to lead into next week's project.
That's cool.
But let's get programming. Alex, if you go back to my screen. So, Brian, we've already reset these pins, right?
Right. So those correspond to what we put them on to the Arduino.
Exactly. It's IN1, IN2, IN3, IN4, which is just how it's labeled on the driver board. So all it says is the pin from the driver is connected to this pin on my Arduino. I could change it to any of the 13 pins I have available on this particular Arduino. Other Arduinos have fewer, some have more.
But right? This is your Arduino.
But this is my Arduino. There is none other. Now, okay, int speed. There's another variable that I created. What this will do is it will allow me to control how long I wait between pulses. That's another way of saying it slows me down. So if I wait longer in between pulses, this thing will go more and more slowly.
That makes sense.
Right.
Yeah.
So right now it is set to wait 1,000th of a second, 1 millisecond between each one of the pulses that it sends out.
And that, okay, so that's what it's doing right now. This is what it looks like,
Right.
1 millisecond.
1 millisecond between pulses.
Okay.
So if I increase that, if I go to 10 milliseconds per pulses,
It'll move slower.
it will move slower. But one thing to remember, if you pulse too quickly, it could skip steps. So we talked about this earlier.
Right.
So there's another one, like I could use microseconds, which is 1/1,000,000th of a second.
Right.
But then the lowest value I can have for that is about 2,000 microseconds. If I go any lower than 2,000 millionth of a second,
Do you start missing steps
I'll start
then?
missing steps.
Do the manufacturers put how many seconds it can do a step, or do you just have to trial and error?
PPS, pulses per second.
Okay.
So that if you were to go back to that picture that we displayed earlier, it would show you how many pulses per second that it can handle. Anything more than that, and it's going to start missing steps.
Okay, cool.
Higher end stepper motors will have higher resolution. So
makes sense.
yeah, it depends how much you pay for it. All right, let's go ahead and go down. Distance. This is it's just a holding variable. So I need a place that will be accessible by all functions that are going to be inside of this program that lists how far it's traveled.
Since its last move or something like that?
Well, how far it's traveled in its entire range.
Oh,
So
okay.
I'm setting it to 0, and then the next number, full rotation, is 4096. So it tells me if I hit 4,096 steps,
You've done
I've done
360.
I've done 360 degrees, and it starts me at 0. So I need 4,096 to get all the way up to
Okay.
full rotation.
Okay, so yeah, it's just setting the lowest and the highest of the parameter.
Right.
Okay.
This next one's a little interesting, Alex. If you go full screen on this one, this contains an array of binary values. So that's what the B stands for. So 01000, 01100, 00100. The reason why I'm doing this is because I need to send a pulse down the line, a precise pulse. And that pulse will normally include like turning on 2 of the wires and turning off 2 of the wires, right?
Right.
This is the easiest way for me to do it. I build one of these, and I send that value down, and it will pulse it in the next step, next step.
Okay.
Okay. I could do this manually, but it's easier this way.
Yeah, no, I think much easier this way.
All right, let's go to the next part. So this is setup. Remember, setup is the part of an Arduino sketch where you kind of tell it what's the hardware I'm dealing with. This is like, for example, this you should recognize from our previous projects. Serial.begin.
Yeah.
What I'm doing is I'm opening up a serial port because I want to debug. I'm going to throw data back down the serial line, right? This is important though. Pin mode, IN 1, 2, 3, and 4. So it's doing a function called pin mode, which allows me to set what that pin will be doing. Then it's using the values that I put in IN 1, 2, 3, and 4, so it knows which pins are connected to the driver board. And then it sets each of those pins to output, because that's all they're going to be doing. They're just pushing out to the stepper motor. They're not taking anything back in.
That makes sense.
Okay. All right. Now here's the big one. Loop. This is the part of an Arduino sketch that it contains the primary instructions. Once everything is loaded, it's just going to keep doing this loop over and over and over again until you disconnect power.
Okay.
That's what loop is.
So if distance is less than full rotation divided by 8.
Yeah, exactly.
Okay.
Now, so here, what I'm doing in my first if statement, if distance, which by the way we set at 0. So when I first turn this on, distance is 0.
Right.
If it's less than full rotation divided by 8, and I'll explain why it's divided by 8 in just a bit.
That's what I'm wondering.
Yeah, so full rotation, which is 4096 divided by 8. So if that number, distance, is less than 4096 divided by 8,
Right.
then I want you to call the function CW, clockwise.
Okay. Okay. Otherwise, it'll be counterclockwise.
Precisely.
Got
So let me
it.
go down to the function clockwise. So here's the function that it calls. For, so we've got a for loop, int stepper equals 7. So it's starting at the value 7. Stepper is greater than or equal to 0. And yes, 7 is greater than or equal to 0. And then every time this for loop runs, it's going to remove 1 from stepper. So it's going to go 7, 6, 5, 4, 3, 2, 1, 0. So it's going to run 8 times. So every time I call this function, it's going to step 8 times.
Okay.
Which is why I have the divided by 8.
That makes sense.
Yeah.
Cool.
Okay, so this, and then all it does is it goes ahead and it does 8 times. It's going to call this other function called move step. And if I go down to the function called move step, all it does, you'll see, is it does a digital write to the 4 pins from that array of binary values that I created.
Yep. Okay.
So-
yeah.
so-
IN1, IN2, 3, 4.
Right,
Yeah.
so that's assembling one 4-bit string for the 4 wires, and then it pushes it down the line.
Oh, that's cool.
And the way that it assembles is it's taking it from, remember that array of binary numbers that I created?
Right.
There we go, okay.
And
So every time I call one of the loops, either the clockwise or the counterclockwise loops, it will step 8 times. And every time it steps, it's going to create a 4-bit string and send it down the line.
cool. And then just below that you have the debug for the serial lookup.
Precisely. Yeah, I just, because I like debug, so we can actually see what's
Can
going
we
on.
see it right now?
Yes, we can. Fine. I mean,
just
might
curious.
as well. All right, so let's look at what's going on inside our little world here. Okay, so, you're going to have to go full screen on this, Alex. So what we've got here is this over here, that's distance. So notice how it's going to count up to about 512, because that's 4096 divided by 8.
Right.
And what it's going to do is it's going to go ahead and it's going to go forward one direction. Wait till you see this gap, and the gap is, it'll come at 1024. The gap will be when it actually switches direction.
Right. And then that's the binary function.
Right. See, so that's the binary value that's being sent down the line. That's 8 values. So that's 8 steps during each one of these distance calculations.
That's awesome.
Okay, and hold on, it's almost there. Give it time.
And then
give it
it'll work
time.
its way back.
It's going to work its way back, but then you'll see how right there. See?
There it goes. Now it's reset
And now
back to
those
0.
binary values have changed because now it's stepping in the other direction.
Ah, that's cool.
Okay, so that's what I'm doing. You're seeing everything that the Arduino is actually getting in and pushing out. So what it's getting in is distance, which is all the way on the right-hand side. What it's pushing out are those 8 binary values every time you call one of those functions.
Very cool.
Okay. Now, this sounds like a pain in the butt compared to what we do with other motors, which is just turn it on.
Right.
But again, what this will allow us to do is it will allow us to have finite control over what we're moving.
Very finite control.
Super
And
finite.
It seems like most of the legwork has already been done on the code. You just need to fill in the values that you want.
Precisely. In fact, the reason why I did it this way is because what we're going to do next week is we're going to hook up a control to this. So we're going to have a way to make it go back and forth because we already have the function.
Oh, yeah.
I have a clockwise function and I have a counterclockwise function.
Right.
So if I call counterclockwise, it makes it turn this way. Counterclockwise makes it turn that way. And all I have to do is trigger it. Just add a way to trigger it.
So could we do it with these dials that we have
We
already
absolutely
here?
could, but I'm thinking more of a joystick.
Oh, okay.
Gotta have the
Yeah,
joystick.
Yeah.
Because for next week, I've also made this. So
Looks like another stepper
take
motor.
this off. There's a reason why this 3D printed platform contains 2 modules for 2 different steppers.
For pan and tilt.
So I can do X and a Y axis.
Yeah, that's cool.
There you go. And I can drive both of those off of the same Arduino because I only need 4 lines
Yeah.
to control that particular motor. So I'll be able to control X and I'll be able to control Y.
And then you could even do like a little rail system where you have a stepper
Yep.
motor that pulls it and pushes it along.
And there's really no limit to your imagination. In fact, all 3D printers, every last one, from the cheapest one to the most expensive, is just using a stepper motor. They're using at least 3 stepper motors, actually 4 stepper motors, for you to get your X, Y, Z, and then this.
That's pretty cool.
Yeah. So, I mean, if you wanted to know how you would program a 3D printer from scratch, it would really just be this.
Let's start with that.
Yeah.
That's cool.
Gotta love
Wow, Padre.
it. Yeah.
I want to play with this project now.
Well, we're gonna leave one down. I actually built a lot of these, so.
Oh, did you? Good.
Yeah,
Good.
because I was thinking we could have robot wars.
Like arms fighting each other. Yeah.
That's kind of.
But from what you told me earlier, we'll have to have a separate power line
Yeah.
so that it doesn't push back
you
through
don't want
the
to blow up
Arduino.
the Arduino.
Yeah.
That would be bad. Folks, again, I have included all of the programming along with the notes inside the link for this episode. And Brian, where do they find that if they want to download that?
Well, you could go to twit.tv/KH, and that's where all our past episodes also live, and handy ways to download or subscribe. So definitely check that out.
Absolutely. And also don't forget that that's not the only place to find us. If you really want to be part of the Know-How community, you have to jump into our Google Plus group. Just go to Google Plus and look for Know-How. We've got over 10,000 members of the community, and it is the most active community that we have here at Twit TV. Thank you also for making it a wonderful place for makers. If you have a question about a project, if you want to pick up a new project, if you are an expert and you want to help people with projects, because that's the ultimate measure of a maker, you got to join.
Or if you just want to show us up on our own projects and make them better.
Yeah, in fact, go ahead and download my STL files, make them better. Download my sketch, make it better. Post it up to the group. We'll show it off. We love it when you do better than we do.
Yes, yes, but that's not the only place that you can find us. If you want to ask us a question directly, or you just want to see what we're doing behind the scenes, you can follow us on Twitter. I am at cranky_hippo.
And I am at Padre SJ. And of course, you can find
our director Alex Grumple.
Grumple, yes.
Grumple.
I'll give you a digital zoom, Padre.
Oh.
There's your...
See, this is what happens when you tick off the Grumple. But you can find Grumple at twitter.com/ANELF3.
It's pronounced Gumple.
Gumple.
No.
No R.
That's not ringing any bells. Sorry. It's Grumple. It's got to be Grumple. Until next time, I'm Father Robert Ballecer.
I'm Bryan Burnett.
And now that you know how,
go stepper motor it.
so much food.